All right, so today we're going to be doing algebraic representations of translations. The rules shown in the table describe how coordinates change when a figure is translated up, down, right, and left on the coordinate plane. So let's say I did 9 units right and 2 units down. And I had a coordinate point of A, 1, 2. So my new point, I'll do plus 9 because it goes to the right. So it's adding. So it'd be 10. And then be 2 down. So it'd be 2 minus 2, which is 0. So that's how you do algebraic representation of translations. All right. So first example is triangle XYZ has vertices X, Y, and Z. Find the vertices of the new triangle after translation of 3 units to the right and 1 unit down. So X would be 0. Whoops. It'd be 0 plus 3, 0 minus 1. Because it goes 3 to the right and 1 down. So the new X will be 3, negative 1. So then Y would be 2 plus 3, and then 3 minus 1. So the new Y would be 5, 2. And then Z was 4 plus 3, negative 1 minus 1. So the new Z will be 7, negative 2. And that is algebraic representation for translations. So now you try one. Try pausing the video and doing the your turn. All right, a rectangle has vertices, and I'm going to label this A, B, C, D. What are the coordinates of the vertices of the image after the translation? So that'd be 6 to the left and 3 down. Describe the translation. So A will be 0 minus 6, and then 3 minus 3. So the new A be negative 6, 0. B was 0 minus 6. Whoops, this was B actually. And then I'm going to make this A, and that'll be negative 2 minus 3. So the new A be negative 6, negative 5. C will be 3 minus 6, negative 2 minus 3. So the new C will be negative 3, negative 5. D will be 3 minus 6 and 3 minus 3. So the new D be negative 3, 0. All right. Now let's do algebraic representations of reflections. So when you reflect across the x-axis, you multiply the y by negative 1. You multiply by the y-axis, you multiply the x-coordinate by negative 1. So let's look at an example. So it says rectangle RSTU has vertices. Find the new vertices if it's reflected across the y-axis. So my first one was R, negative 4, negative 1. Since I'm going across the y-axis, that means my x-coordinate needs to be multiplied by negative 1. So my new coordinate would be positive 4, negative 1. And then S was negative 1, negative 1. So then my new coordinate would be 1, negative 1. And then T was negative 1, negative 3. So my new one will be 1, negative 3. And then U was negative 4, negative 3. So my new U will be positive 4, negative 3. And again, that's written right here. Okay, so now you try one. So pause the video and find me the new vertices for when it's reflected across the x-axis. So the new A will be negative 2, negative 6. B will be 0, negative 5. And then C be 3, 1. Oops. Okay. Now we're going to do algebraic representations of rotations. So when a 90 degrees clockwise, you multiply the x-coordinate by negative 1, and then switch x and y. If you do 90 degrees counterclockwise, you multiply the y coordinate by -1 and then switch the x and y. If you do 180 degrees, you just multiply the x and y by -1. So first example is quadrilateral ABCD has vertices, and then find the vertices of the new quadrilateral after a 90 degrees clockwise rotation. So the new A will be, you have to do, so if you look at your 90 degrees clockwise, so it says multiply the x by -1 and then switch it. So my new one will be 2, 4. And then B will be 4, 3. And then C will be 3, -2. And then D will just be 0, 0. Because if you have a point on the origin and you do a rotation, it does not change because you're rotating it about the origin. Okay, now you try one. A triangle has vertices JKL, and where are the coordinates of the vertices after the image is rotated a 90 degrees counterclockwise? So that means you're going to have to multiply the y by -1 and then switch the coordinates. So J will be 4, -2, and then K be -5, 1, and then L be -2, 2. And that is how you do algebraic representations of translations, rotations, and reflections. Thank you.